This is the study guide answer key video for ELR 3.5. In this ELR, we're actually going to be focusing in on Newton's second law. We've already been using it a few times in this video series, but now we're focusing specifically on that. This is the combination of Newton's second law and free body diagrams. And so the last couple of questions are going to be more difficult than the first, but they all have the same principle. In the first idea, this one, David is pushing a laptop cart, so I'm going to make myself a free body diagram right off the bat. He's pushing this laptop cart with a force of 150 newtons. And Ian is pushing back with a force of 200 newtons, so pushing in the opposite direction, 200. Each of those is newtons. And the mass of the cart, we're giving us that information, is 125 kilograms. Based on that, we need to draw a net force diagram, which we just did, and show all the forces acting on the cart, and figure out what the acceleration of the cart is going to be. So I'm going to rewrite Newton's second law, but I'm going to add net force equals mass times acceleration. And that's because if you have an object that's experiencing pushes and pulls in all sorts of different directions, and when it accelerates, it's not going to accelerate in all those different directions. That would be weird. It's just going to accelerate in the net direction, so like whatever's left over. So if you don't remember net force, it's like take the right stuff and subtract the left stuff, and whatever you're left over with is the net force. And that's exactly what we're going to do. So net force is all of one direction minus the other. So I'm going to take 200 minus 150, because that's going to give me my net force. And the net force is going to equal the mass, which was 125, times acceleration, and then we can solve. So 200 minus 150 is 50. That equals 125a. And then we just divide both sides by 125, and we're going to get our acceleration equal to 0.4 meters per second per second. For number two kids are kicking a ball. One's kicking to the left, the other's kicking to the right. They're each pushing on it with different forces. They're also giving us an acceleration to the right. Now we're trying to figure out what must the mass of the ball be. So we're just kind of doing the same thing, except we're going to be solving for a different part. So I'm going to be setting up my diagram again. One of the forces is going to the left with a force of 10 newtons. The other is going to the right with a force of 30 newtons. And the ball has an acceleration of 12 meters per second. And it says it's going to the right, so I'm going to add that in also. So now we're going to solve for mass. So again, net force is subtract the two different ones. So I like to start with the bigger one. So 30 newtons minus 10, that's going to be our net force, is equal to the mass, which we don't know, times the acceleration of 12 meters per second. 30 minus 10 is, of course, 20. It's equal to 12m. When I do 20 divided by 12, I'm going to get mass is equal to 1.67 kilograms. All right, for number 3, we've got the most challenging of these free body Newton's second law questions. We've got a teddy bear, and it's being pulled on by two kids. It's being pulled to the left with 2 newtons. So we're going to go that way with 2 newtons. And we don't know how much force is being applied to the right. So some other kid's pulling that way, and we don't know. If the teddy bear has a mass of a half kilogram, so mass is 0.5 kilograms, and the bear is accelerating at a rate of 1.5 meters per second, and it's going to the right. So automatically I know that the force on the right is going to be bigger because it's accelerating that way. How much force is that? That's what we're solving for. Okay, so we're going to set this up exactly the way we did before. We're going to do subtraction to get the net force. So we're going to start out with just like x. I don't know what that force to the right is, but we're going to subtract 2 from it to figure out what the net force is. Then we're going to set it equal to the mass, which was 0.5, times the acceleration, which was 1.5, and then we solve. So 1.5 times a half is equal to 0.75. And we have x minus 2 on the other side. So we add 2 to both sides, and we're going to get our, I'm going to put it down here, we're going to get our grand total to be 2.75 for our force. That's newtons. For the last one, if the force on an object is cut into a third of its original amount and the mass is kept the same, what will happen to this acceleration. This is the same type of question that we've done in the past where you need to just make up some amounts and see what happens. So we're of course using F equals ma. So I want to do something that I can cut into thirds really easily. Why not 3? So it's saying if the force on an object is cut into thirds. So if our force is already 3, and it says in the mass is kept the same, what happens to acceleration? Let's pick a really easy mass. How about mass of 1? If we have a force of 3 and a mass of 1, and we'd be solving for acceleration in that, then of course 1 times a is just a, acceleration would be 3. So now let's figure out what happens if we cut it by a third. Well, a third of 3 is 1, and the mass stays the same. So now it says 1 equals 1a, now a equals 1. So it looks like if we cut our force by a third, we also cut the acceleration by a third. So acceleration goes down by 1/3.